Hello, good morning, good evening, everybody, and welcome to this session where we are going to explore the connections between the decade and ocean forecasting and how the decade is contributing to promote ocean forecasting around the globe. We are going to do, well, first of all, let me introduce myself. My name is Enrique Alvarez, and I am the technical coordinator of the OceanPrediction Decade Collaborative Center, working at Mercator Ocean International. We will explore this connection between ocean forecasting and the decade from two different angles. First of all, we will explore the work that is being done in two key programs of the decade. Those are FORESEE and CoastPredict. And then we will explore the work of the OceanPrediction Decade Collaborative Center regional teams. And finally, we will have a small dialogue between all of us addressing key aspects related to ocean forecasting and best practices. So let's start without any additional delay, and I will take the opportunity to do a presentation to give a little bit of context on where we are on the decade with respect to ocean forecasting. So I will share my screen. And I will start by describing a little bit the framework of the Decade Collaborative Centers and Decade Collaborative Offices. Those are the coordination bodies of the decade taking charge of the different programs. And those are divided in, on one hand, the regional decade collaborative centers that are dedicated to certain areas of the world, such as, for example, the Indian Ocean region or the Southern Ocean DCC. And you have connected with those the thematic decade collaborative centers. And here you have dealing with forecasting the ocean prediction DCC, that's the one I'm working in, the ocean data sharing, the ocean observing, the coastal resilience, and many others that are linked to specific thematic applications. If we go to the programs, there are many programs on the decade which are under coordination of these decade collaborative centers that are particularly important for the ocean forecasting, for the promotion of the ocean forecasting. But I want to mention a few of them, such as FORESEE, DITO, Best Practices, CoastPredict. And today we will have, after my presentation, a presentation by Giovanni on CoastPredict and by Marie on FORESEE. So those are really maybe the two more important programs in terms of promoting ocean forecasting in the decade. Let me explain a little bit what we pretend to do with this Decade Collaborative Center, with the OceanPrediction Decade Collaborative Center. And if I have to explain this in one single slide, that will be it. On the left, this is the ocean forecasting we have today. We have systems that are powerful, that are important, that we are proud of these systems, and we know they are useful. But somehow we have to admit that there are weaknesses on our way of doing things. Those systems are not properly connected, and those systems are difficult to operate and difficult to integrate. So that means that in those institutions that you don't have a lot of technical capabilities, we have poor presence of these systems. We need to change to a scenario where we will have many more systems working, connected, both technically, providing interoperable data, and also with a community behind them that will allow all these systems to be more robust and to be more present worldwide. So we want to have many more robust systems and more connected. To do this transformation, we want to do it under the UN Ocean Decade. The engines able to do this transformation will be the Decade's action, and also we want to take advantage of the concept of the digital twin. And our crew will be the community that we are building around Ocean Prediction DCC. And our role at the DCC is to set the course from one scenario to the other. So our role is mainly inspirational to move from one scenario to the other. To do that, obviously, we cannot reach everywhere from Toulouse, where the OceanPrediction, DCC, and Mercator are located. We have to work together with our friends worldwide, and therefore we have created the regional teams, the OceanPrediction, DCC regional teams that are promoting the implementation and use of ocean forecasting systems worldwide. To build these regional teams, we have taken the best of both worlds, the UNEP regional Seas and the GOOS regional alliances, and we have constructed these regions. And you will see that the second part today is about some of these regions explaining the activities that we are carrying out. Now that these regions are forming, they are being our boots on the ground for many of the works we are doing and we are planning to do in the future. Support dedicated action related to ocean forecasting, identify gaps and ways forward, capacity building. We have not started doing things like this. Maybe next year will be the year where we will start doing this, and advocate for the implementation of best practices, standards, and tools. And you will see that I will focus also a lot now on these best practices, because also we are on this seminar on best practices. Those are the leaders of the different regional teams. We have 9 regional teams with several institutions chairing or co-chairing these regional teams. And when you put all the steering teams that are part of these regional teams, you see that we have a large family of people trying to get coordinated, trying to move forward in promoting ocean forecasting. There are many ways of doing this promotion of ocean forecasting, and we have decided that our way to promote ocean forecasting is through this virtuous loop. This virtuous loop is based on our community, on the OceanPrediction community that we are building based on the regional teams, and has 4 stations, 4 principal stops. The first one is the knowledge. We believe that we need to provide the knowledge to the people. This knowledge is related to the physics, to the biogeochemistry, to the modeling, to the techniques, to many different aspects. And we have worked in the past on the TÜV's guide that was published 2 years ago. And this is a first compilation of the basic knowledge you need to know to start in this world. Then we are going to publish, I think it's going to be published this week or next week on our webpage at the OceanPrediction. This is a webpage, the architecture guide. And this is the text that explains how to build from inside an ocean forecasting system. It explains all the wiring that is necessary to build an ocean forecasting system. Once you know how to build an ocean forecasting system, you need to operate it. And here we have something that is also about to be published, probably during the next month, as a peer review paper, which is the operational readiness level. You will see this is a collection of best practices, and then all this has to be integrated into digital twins and services. We are not doing all this alone. We are doing all this in collaboration with our friends on the decade, and in particular with these programs that I am mentioning. So to go a little bit more in detail on this architecture, as I have explained it, those are the wiring diagrams on how to implement ocean forecasting systems. And this is going to be published really soon, and it's going to be an asset to teach people on how to properly build these systems. Then we have the operational readiness level, that is a collection of best practices. And on top of that, we have created a test that tells the people if they are following properly these best practices when operating an ocean forecasting system. And you have 3 independence numbers that refer to production, system validation, and product dissemination to the different aspects of the operation of an ocean forecasting system. It's a way to promote best practices in ocean forecasting, and it's a mechanism to endorse services to join common frameworks. Finally, we are moving forward into this integration, and we are working together with the Ocean Observing DCO and the Data Sharing DCO in building of this One Ocean, One Digital ecosystem. And of course, we are also doing that in collaboration with the different programs of the decade. So as conclusions, the OceanPrediction DCC will work in close collaboration with decade partners to promote ocean forecasting and its application during the decade. We have organized this community around ocean forecasting, and we have organized it through the regional teams, and we will give the voice to the regional teams today. First results of this effort are now visible. Finally, we are publishing, probably as I mentioned this week, the architecture on the web page. The operational readiness level is going to be soon published as a peer review paper. We have an atlas where we are incorporating all the ocean forecasting systems around the globe, a forum to stimulate the dialogue, and more ideas that are to come. So please, I encourage you to register at our webpage and to be part of our community at OceanPrediction DCC if you're interested in these aspects of oceans forecasting, which I assume is the case because you are in this meeting today. So thank you very much. And with this, I stop sharing and I'll give the floor to Marie so she can talk to us about the program VIII. Marie is an oceanographer at Mercator Ocean International. She's the head of the evaluation of analysis and forecast system. She's co-chair of the OceanPredict science team and chair of the validation team for the Copernicus Marine Service. So Marie, the floor is yours.
Thank you, Enrique. Good afternoon, good morning, wherever you are. So I will talk about VIII, the VIII program. Sorry, I don't see my screen correctly. I have no idea how to do this. Okay, sorry. Well, for the vision of VIII of this program is really to achieve a strong international coordination and community building of the ocean prediction capacity for the future. So, of course, it has very strong links with the ocean prediction DCC that Enrique has just described. And the overarching goals are advancing the science, the capacity, the efficacy, the use, and the impact of ocean prediction systems, contributing to a seamless end-to-end ocean information value chain as the integrated and interconnected ocean prediction system component. So we are really focusing on the ocean prediction systems here. And we are using an already existing community of ocean prediction centers working together for years and building together some discussions on the main themes of collaboration, scientific collaboration, and building also the standards of the community together. So with this program, with this VIII program, we want to use the OceanPredict science program, already existing OceanPredict science program, and give it a lot of impact and relevance in the decade. So VIII is really a communication action of this community towards the other actors in the value chain and in the decade. So this OceanPredict community, here you see a photo of the last symposium, which took place in 2019, sorry. So it's organized around task teams, really exchanging around all the topics of ocean prediction, including, of course, prediction, coupled prediction, but not only, also ocean models, data assimilation, intercomparison and validation, marine ecosystems, but also observing systems evaluation, and of course, coastal ocean and subseas too. And so all these thematic task teams are really advancing the ocean science and providing a lot of, let's say, scientific results that we would like that can really benefit a lot of operational oceanography centers, apart from these who are already involved in this program. And so the idea is also to do more, to leverage this international coordination mechanism across national centers, to exchange and to improve prediction system science, and to really achieve impact and relevance from advances in ocean prediction, and to really integrate our work with others to form a value chain, but also to go towards the community and yes, participate into capacity building and help others to build their ocean prediction centers. Yes, as I said, so the vision already, I will not repeat what I already said, but this is really in line with the objectives of the Ocean Prediction DCC, and there's a strong collaboration with the DCC. In particular, there is also a group within OceanPredict VIII, which we call the Ocean Prediction operational services group, which is really dedicated to defining standards and defining practices in operational oceanography and ocean prediction, which is really actively participating in building the architecture together with the Ocean Prediction DCC. Okay, and that was precisely the slide supporting what I just said. Sorry. So there's really a need to structure more and to define more standards and best practices. And so this is precisely the objective of this working group within OceanPredict. So the OPOS working group. And so with this VIII action, this VIII program within the decade, we really want to contribute and support the Ocean Prediction DCC. And we also want to engage dialogue with the other programs within the Ocean Prediction DCC, so the DITO, GEMS Ocean, best practices, sea level change, OAS programs, but also the VIII program hosts some projects, among which one is dedicated to the evaluation of the impact of observations, so the SYNOPS project, but there are also projects related to the prediction of extremes here in the North Pacific area, also projects for developing operational oceanography capacities here in the area of Chile, and also the forecast, developing of ocean observing and forecasting systems. So we also collaborate a lot with COSPREDICT, which will be presented just after my talk by Giovanni. Also building on the community of OceanPredict in a way, as there is a task team dedicated to coastal operational oceanography in OceanPredict. So within this framework, we also submitted recently a project to be endorsed by VIII, which is really focusing on intercomparing and evaluating ocean reanalyses. So this has been done already in the past, but in the framework of the decade, we wanted to analyze new products that are, because a lot of progress has been made in the last decade, and to gather also the users of these products with the producers to define really use cases and key areas where these products could be evaluated into a more detailed and more user-oriented way. And also include marine ecosystem reanalysis in this evaluation project. So we started in 2023 with a workshop and a summary published in BAMS. And we also, we are in the process of defining a list of diagnostics, metrics, key areas and use cases, and also a list of participants, and connecting with people using the International Reanalysis Conference that will take place in Tokyo in October, and also the OceanPredict 24 Symposium taking place next month in Paris. And so we are really, this is an open project, so we are really happy to connect with new groups. So this is also why I wanted to show you this slide today. And we wish to start this intercomparison exercise in 2025. So we also hope really to rely on the expertise of the regional teams in the Ocean Prediction DCC to really understand what can be done to evaluate the ocean reanalysis regionally. So my last slide, just to talk to you about this Ocean OceanPredict 24 Symposium taking place in Paris next month. So it is now closed for in-person registration, but it is still feasible to attend online. So you can register to attend online. And there will be exciting sessions on ocean prediction there, and also best practices in ocean prediction. So thank you very much.
Thank you, Marie, for this excellent overview of 4C and the connections of 4C with OceanPrediction DCC, with CostPredict, and with others. Very exciting work, the one that is being carried out at 4C. The next presentation, don't forget that if you have any question, you can put those questions on the corresponding box of questions and answers by chatting. The next presentation is by my friend Giovanni Copini. He's the director of the Global Coastal and New Frontier Research Program at Euro-Mediterranean Center on Climate Change in Italy. He is leading the Copernicus Marine Mediterranean Monitoring and Forecasting Center, and he is a member of the Executive Director Board at Eurobus, and he was ex-chair of Mongoose.
Thank you, Enrique. It was a lovely presentation and most important, showing our friendship. So I'm going to present you briefly CostPredict, which is one of the program, and of course by name is focusing on the coastal area, and we aim to transform the observing and predicting capacity of the global coastal ocean. So you can find all the information on the website. I acknowledge that of course this is a very large group of people working together, and the board and the UNESCO team is here presented. I'm part of the secretariat with Mayred and Ariba at CMCC, and we work all together for the same objective. So, which is to provide actionable science solution, based solution to the decision maker, to the practitioners, and the coastal communities. Exploiting an integrated observing and predicting system with a final goal of identifying solution for managing risk, in the short term and in the planning phase for mitigation and adaptation on the long term. Of course, in the context of the climate change and climate and ocean change. We are one of the free program of GOOS, and of course together with the other two, Observing Together and Ocean Observing Co-Design. We are together with 4C among the global endorsed Ocean Decade programs, and we have already engaged more than 300 institutions in so we pretend to define us as a global program within the Ocean Decade. Here I just put some of the colleagues but just to mention that among the more than 300 institutions through the pilot sites and the steering committee, we have of course the key players in coastal oceanography engaged. So why? I mean, why we develop CostPredict is because there were some needs, some drivers and opportunities, and some problems to be solved, and there still are there, and we need to solve them together. So first of all, the fragmentation of knowledge and effort, especially when you look to the global dimension of the problems of the coastal ocean. On the same time, we need to fill the gaps in observation, especially in the global south, and we need access, equitable access to resource and knowledge for the global south especially. We have a technological gap, and we need to focus on the urban coastal environment. We need to make this new technology, observing technology, available. Focusing on citizen science is key, and also focusing on capacity of delivery. I will mention the cloud that we aim to develop to provide access to big data. And of course, we need to develop, or better say, co-develop with coastal managers and practitioners community service, also collaborating with the private through a public-private partnership. So at the end, last year we decided to start Global Coast, which is a framework of implementation, is an initiative of CostPredict. It's a reality today. It's a program. It's an initiative to create a globally replicable solutions, standard and application that enhance coastal resilience for both natural and anthropogenic or built environments. So how the global coast framework will work will be built on an interoperable cloud, so connecting different cloud worldwide, but with a focus on the coastal area, and gathering data and observation and model products from the pilot sites you will see in a moment. Also being implemented through the projects. We have several core and affiliated projects within CostPredict that are implementing pieces like the core for the infrastructure and the data management, or restore our coast for the restoration and so on. And then we will the cloud will offer solutions through accessible solution, public oriented, but also developed with private, and they should be replicable also in terms of region. So we have started conceptualizing and using the conceptualization of the global coastal ocean by Robinson and Brink, and you see that the coastal ocean can be subdivided in regions, and these regions refer to the oceanographic or hydrological characteristics. And we have used this regional approach to gather together, to put together the pilot sites we have identified. We have more now today of, we have 130 pilots, as you see, all over the global coastal ocean, or most of it, from 66 countries that wants to collaborate to implement a global coast. So it's a network, it's a coastal network. These place marks are not only people and but also project themselves. So they're not research institute, but groups of stakeholders and research institute that have a plan to work together to achieve a global coast. In fact, we have already analyzed the user and the stakeholder community and categorize them for each pilot, as well as most important, we have an understanding of which are the priorities, and these 130 pilots has declared that their most important urgent priorities are the disaster risk reduction and real-time forecasting of extreme events, and to assess and understand the impacts of climate change on the coastal area. Example of the solutions that we imagine we will develop all together. Impact area 1 is about, as I said, the early warning system. So we need to develop a prototype of coastal models integrated with smart observing system. You have here an example that we have done in Savannah, and of course to be expanded to new measurements, especially to the satellite component. Impact area 2 is about downscaling for climate risk assessment. So here we need to produce high resolution climate downscaling and then make them available, and then share this information through indicators with the public and the stakeholders. Oil spill impact area 3, so the pollution component. We need to develop capacity of hazard mapping for the entire global coastal ocean, and of course reformulate the present approach with artificial intelligence. Impact area 6 on, let's say, adaptation to climate change through nature-based solution. For sure, the digital twin today offer the opportunity, especially if you focus on the coastal area, to plan landscape of nature-based solution and coastal restoration, and we need to expand this and make it available worldwide. So with that, I conclude, and I leave you our contacts for future interaction, because it's an open program, and I'm sure through for the OceanPrediction DCC and the collaboration with VIII, we will be able to maximize the impact. Thank you.
Thank you very much, Giovanni, for this very clear explanation and for explaining these very exciting ideas about, with this network of centers, with the ideas of cloud computing. All this will be a significant step forward in terms of the capability of the people to deal with the coastal problems. So congratulations for all this work. This closes a little bit the first part of the meeting, where we are talking about dedicated structure, dedicated programs to explain what they are doing. Now I would like to move to the regional teams of Ocean Prediction DCC. Just remember, the regional teams are those bodies that are created by the DCC in order to try to promote ocean forecasting in the different regions of the world, to try to be influential on the different regions of the world. And let's travel now to South America. Let's start with Clemente. Clemente Tanajura is a close collaborator involved in the development of the South America regional team. He's a specialist in oceanographic data simulation and atmospheric ocean modeling. He is professor at the Physics Institute at the Federal University at Bahia in Brazil, and he also works as a researcher at the Modelagem de Observação Oceanográfica. Sorry for my pronunciation in Portuguese, Clemente. That was absolutely dementia.
It was excellent.
No, thank you, Clemente. The floor is yours for your presentation to explain our activities in South America.
Thank you very much for the kind introduction. Enrique, I'm going to share my screen. Okay, hope everybody's seeing correctly. So I'm going to talk about some activities of our South and Central America regional team. So we have been working with several collaborators. I think our main purpose in the first steps that we took was to actually put together a regional team. So we invited people from several different expertise and from different countries. And we have people from Argentina, Brazil, Colombia, Peru, Panama, Chile. And we are still missing some experts in digital twin and also in policy and legal aspects. But our team is formed mostly by researchers and developers. And so we don't have many, let me say, directors of centers or some administrative position. Our group is mainly focused in researchers. And we did 2 meetings on December 5th of 23 and April 3rd, 24, with the goal to form the team and to launch on July 2nd this year our regional team. And then we would like to prepare a new meeting until the end of the year to push forward the collaboration. So we have also, I forgot to mention, people in some Navy from Colombia, Navy from Brazil. And this is our atlas in which today we have only 3 institutions that are registered in the atlas. We have the CHM in Brazil, we have the DIMAR from Colombia, and also Serviço Meteorológico de Armada de Chile, that you can see here in this atlas information output. So, however, there are several institutions in Brazil that are working hardly to promote operational oceanography and are willing to collaborate to DCC, foresee, and coast predict. So one of the tasks of the regional team is to motivate these people to get engaged in these programs. So we did in this meeting on July 2nd an overview, and we have a system from Argentina that is hosted by the Argentinian Meteorological Service, National Service, and they conduct forecast of waves, barotropic model, and also Antarctic ice. In Brazil, we have a more mature system together with Colombia, the INDIMAR, that has been doing ocean operational forecasts for a while. And then our Brazilian Navy that hosts our operational systems, they do ocean wave forecasts, 3D ocean circulation, with data simulation for the all Atlantic, South and North Atlantic. There are also specific products for the coastal and ports with the barotropic model, and also we are developing an oil spill model for application along the whole Brazilian shore and also in the deep ocean. We have also the Brazilian Ocean Observatory, which has a partnership with CMENS. So they have the ocean information, large-scale information from CMENS, from the CMENS forecasts by NEMO. And then they do a downscaling for specific regions along the Brazilian shore and also in the Atlantic region with the Mohid oil. And in IPE, we have more focus in waves and also in coupled climate forecasts or extended forecasts. In Chile, the operational activity are led by IFOP, which is in the fisheries. The fisheries organization in Chile that is promoting a very sophisticated project called CONOS that was already mentioned by Marie Verellon, in which they use atmospheric models and regional models and also biogeochemical models to attack the problems of the algae bloom and oxygen in the very coastal areas, in the fjords areas, in the south of Chile and also in the northern part of Chile. In the Colombia, there is the DIMAR that deals with forecasts, operational forecasts of ocean waves and regional models around Colombia in specific regions in the Caribbean and in the Pacific area. And also they have a downscaling to coastal and ports area. In Mexico, there is a big focus in the Gulf of Mexico. We are aware that Mexico is actually part of the North America team, but we hope that Mexico also can contribute with the expertise in biogeochemical models and oil spill models, because they take part of this consortium in the Gulf of Mexico forecasts for oil spill trajectories. In Peru, there's the Institute of Geophysical, Peruvian Institute of Geophysics. They do climate forecasting with focus in the El Nino. And they do have ongoing activities with artificial intelligence and also for Kelvin and Rossby wave forecasts, not along the Peruvian shore. So they use a multi-model approach to try to capture the best possible Kelvin and Rossby wave forecast for their area. So in terms of common ground, we see that many centers work with wave forecasts, and oil spill are among the major interests. Biogeochemical forecasting, however, is stronger in the west coast of South America, and data simulation is today stronger in the east coast. So inside South America, we have a lot of room to collaborate because we complement our activities. And then we hope that with the DCC collaboration and the Foresee and CoastPredict, we can also bring all these efforts together. In terms of application, we do of an oil spill that was motivated mostly after the very severe disaster in August, September 2018 that maybe hundreds of kilometers, maybe thousands of kilometers along the Brazilian shore were suffered with the oil spill that reached the shore. And the Brazilian Navy could work with our operational models in this task. Also, they are trying to do kind of a backward integration to try to detect the origin of oil spill. And another very successful use of ocean forecast was the search and rescue activity that we had in June 16, 2023, where we used the Brazilian operational system to forecast the search and rescue area of a fishing boat that submerged in close to the Brazilian shore. So this yellowish area that you see was the area that was defined by the Brazilian Navy to do the search and rescue operation. And here you can see the regions where the wreckage were found, and also they could save 6 of the 7 fishermen that were in this vessel that sunk. We have identified that the strengths in our region. We have a large diversity of models and configurations and applications, and also diversity of stakeholders. We have motivation to improve the forecasts. We have some motivation to improve the observation and data simulation systems. We have also motivation to disseminate the data, analysis, and forecasts. And also we have an acknowledgement that collaborative networks are needed inside each country, but also among South and Central America countries. And then there are several ongoing efforts in this direction. But we have lots of gaps. Gaps associated to human resources, to infrastructure in several dimensions. Also, we sometimes are not able to share all the information we'd like to. So this should be one of the focus of the best practices in the South American and Central American regional team to improve the dissemination of information. And also, as many other regions of the world, we need to have a very high resolution topographic data. If you want to study the deep ocean, you need to have very high resolution bathymetry to be able to tackle the nuances of the directions and intensity of the deep flow that are normally not well captured by even regional models. Also, we should improve the biogeochemical forecasts and also data simulation of biogeochemical quantities. And also, we need to have more observations in the deep ocean. As we can see in the South Atlantic, we here have only at most 200 deep Argo, and also higher resolution reanalysis. So this is an effort towards improving the ocean observations along the Brazilian coast. So we have this SimCosta project that has the perspective of increasing the number of moored buoys along the coastal areas for 20 operational buoys, that the data is freely available in the internet, and it can be freely used by users for model validation and also to do a simulation. But to do a simulation in those relatively shallow waters is a challenge. You should have a model compatible to that characteristics of the observations. And in 2025, we'll have, in addition, 5 new buoys. So we also are improving our data simulation schemes with the ensemble forecast, ensemble Kalman filter, and also doing OSIS with the SWOT and 2 SWOTs. Already 1 SWOT is already running, so have been testing use of 2 SWOTs. And also this is an example of XPT line along the Brazilian shore that captures very high resolution structure of the Brazilian current and its meanders. So we are doing also OSIS with 3 gliders that we want to use to try to have an operational glider to help the operational forecast and make this experiment that we show in this large picture here of the meridional current that you can see on the left with a positive flow in blue and would be northward, and southward flow in black, in red and orange. And you can see how the structure of northward and southward flow keeps exchanging a very relatively short dimension of a few hundreds of kilometers. And we hope that with the use of gliders, we can have this type of structure that is captured only when we assimilate these XPT data. So we have XPT data transformed into salinity with synthetic salinity, and we could see in the first row here the observational circulation based in geostrophy with the XBT data, and in the other lines we don't assimilate that information, and when we assimilate we can improve a lot the variability of this flow. Also, there is an artificial intelligence effort going on in Peru, and then we have lots of room to improve, because so far we are not using artificial intelligence in any operational system in the East Coast, and also there are lots of room to improve the forecast with the artificial intelligence, not only in the data simulation algorithm, but also in the forecast itself. Okay, so here we should say that we could identify several strengths and gaps, but there is a need to improve inside South America and also with the other regional teams. And then we have already decided to promote short-term school in South and Central America to tackle one of the most important gaps we have in our system, which is human resources. Brazil has a difficulty to keep the human resources inside Brazil because there is not too many openings in the Brazilian structure. So we have many of our brilliant students are now in CMCC, in Mercator, in Australia as well. And then it's really a way that we can reduce this impact of loss of human capacity if we collaborate. So that's it. Thank you very much for the information, for the attention, and I hope I have passed some information for you. Thank you so much.
Thank you very much, Clemente. That was my perfect presentation. And I would like to highlight that at least partially this has been already possible thanks to this work we are doing on the DCC of compiling information. And I would like also to announce that a summary of all this information that is being compiled will be soon published on a journal, on the State of the Planet journal, where we will have all this information from the different regional teams as a compilation and showing what is the status of ocean forecasting around the globe. So we are working on that and hope that we will be soon there. Just also to mention, you were saying that we are missing a few systems still on the Atlas. That will be fantastic if we slowly advance in this direction. We were watching this morning the presentation by Manuela on the Med Sea. They are quite advanced. They have more than 60 systems already on the Atlas, only on the Med Sea area, and that is allowing to start doing statistics on how the models are used, why the models are implemented, the different kind of resolution. Many things are starting to be possible thanks to these information compilers. So let's keep on pushing on this direction. Our next speaker is Heather Reagan. Heather is the chair of the Arctic regional team. She's an ice modeler at the Sea Ice Modeling Group at the Nansen Environmental and Remote Sensing Center in Bergen, Norway. She is deeply involved in interaction between sea ice and ocean and the effects of fresh water on the upper ocean in polar regions. So Heather, please, the floor is yours.
Thank you, Enrique. Just share my screen. Yeah. So can you see my screen okay?
Yeah.
Perfect. So I will spend the next 10 minutes telling you what we've been doing for this, the Arctic regional team as a contribution to the OceanPrediction DCC so far. So, of course, it's not just me leading the team. I would say that we have quite a small forecasting activity in the Arctic compared to other regions, but we still have a very competent steering committee put together to guide our efforts to try to expand it. So we have expertise across a wide range, from policy to the different components of the forecasts, like physics, biogeochemistry, and the observations going in. And we've also got some links with downstream users and capacity building from some people who produce ice charts and also interact with users on a regular basis. And because we are the Arctic region, we have a circumpolar reach with our steering committee, which makes organizing meetings a bit hard across time zones sometimes, but it means we have a good access to a variety of institutes across the Northern Hemisphere, actually. So one of the big contributions we've done so far, as for the other regions as well, is to have contributed some short reports about the current status, gaps, and ways forward for both Arctic forecasting systems and also for downstream users. And I will summarize some of the findings of this that I think are unique to the Arctic, both for forecasting and the challenges that we face. So it's interesting to hear that the Mediterranean Sea region has 66 systems already on the atlas, because we have much less available to us in the Arctic. Almost half of the forecasting systems that have an Arctic component are actually global models, which may or may not pay careful attention to what's happening in the Arctic. And we also have 8 regional models and 4 coastal models, which deal with subsets of the Arctic. The resolution range is from around 3.5 kilometers to up to 18 kilometers in the Arctic basin, with a temporal range of between 5 to 10 days normally. Some systems run at higher resolution for 48 hours, outputting much more regularly. And one system runs until 16 days at high resolution and then continues a low resolution version out to 46 days for a sub-seasonal prediction. And most of the models provide outputs in both a data format and some kind of visualization tool to see what the forecast looks like, which is useful depending on the kind of users that are interested in the products. There's also one model that is not run regularly, but is run on demand for specific campaigns, usually scientific research at the moment. and only one model at the moment provides biogeochemistry outputs. This may increase as interest in the Arctic increases. And in terms of the downstream users, at the moment, applications mainly cover navigation support, research, search and rescue, and ship routing, although there may be some others that are used sometimes. Two things to draw attention to for Arctic specific considerations. Firstly, the availability of data for input to the models is very important. And this is in terms of both the timeliness of it arriving and being accessible, because we rely a lot on satellite data. And also the amount of data that's available. In terms of observational systems, there isn't so much under the ice which can cause problems with knowing how the ocean should be produced. And also if there aren't enough observations going into the forecast, then the assimilation can be disrupted by that. And for forecast outputs, there are actually some nice cases of these happening in a consistent way. For example, the CMEMS platform is a nice multidisciplinary overview of where there are lots of forecast outputs and also data sets across different scientific disciplines to both visualize and download data. But if you're on a ship in the Arctic and you need access to data quickly, you might not be able to download a full product or load up a full web page to be able to access data with limited bandwidth. So that's an important one. Also, the variables available to users might not be exactly what the user wants. So, for example, the ice edge position is very important for a lot of users, but because of low resolution grids or errors with atmospheric forcing which carry across into the forecast, the ice edge can be off by a number of kilometers, which can be problematic for users actually in the Arctic. And things like ice strength, which can also be an important consideration for ships wanting to go in near the ice, aren't often routinely output by sea ice models, which have been developed for climate purposes rather than forecasting. And therefore, there's a mismatch between what forecasts are sometimes providing and what the user wants. And one of these big problems is a resolution problem as well. And users often use manual ice charts derived from satellite products with the input of experts, as opposed to the model forecasts. And this is something that would be good to address in some way. So far, the community contributions, we've been getting up to speed with the other teams. We're in the process of adding to the atlas. A few systems have been added. If we count the global ones that have an Arctic component, a few more have been added, but we still need to get the uptake of that more. Two of our steering committee members have signed up as experts to answer questions on the forum, and we have submitted one news item so far, and this is ongoing and we want to improve our engagement with that. But one of the big things that we have engaged with in the past year is our connection with Arctic Rus, which is a branch of Eurogoose, and it's an initiative that which says here to integrate European oceanographic and sea ice monitoring and forecasting activities in the Arctic. And this has been very fruitful. It is just European, but we do have steering committee members from other regions as well, and we hope to try to expand the reach of our activities with this by using their expertise of connecting with different activities and different people already. And one of the highlights of this so far has been a workshop that we held between the 17th and 18th of January this year. And it was a session on sea ice forecasting, which also covered combining observing and forecasting, downstream user services and applications, and the road ahead. And we aimed to try to bring together everyone involved in the forecasting supply chain and users. And while we may not have managed to reach everyone, we managed to reach a lot more people than our initial kickoff meeting had in the past. So I think we're going in the right direction for this. I think we had 80 people signed up for one of the days. And we sent out a survey as part of this workshop, and we got 26 responses from a number of categories. And some of the key findings, there were very interesting findings, but some of the key ones for this were the meeting was very appreciated and more are useful, especially bringing a variety of users into a forum where they can discuss things. And this is because what can be provided by observationists and modelers for modelers and downstream users are not always what is wanted. And this needs to improve for the forecasting services to improve. And one of these things is more real-time data integration, both in terms of more data and a better ability to use the data that is available. Uncertainty is another big one. If people can't be sure how certain there is to be sea ice nearby, then they won't be able to trust the model. And it's not just giving uncertainty estimates, it's giving them in a way that a user can interpret them physically for what they should do with their decision making. And end user needs is one that comes up a lot. So we want to continue with this, and we are planning another workshop at the beginning of next year on AI and machine learning for sea ice and forecasting. There are a number of interesting activities going on at the moment, and being able to exploit these sorts of things could help to plug some of the gaps and advance the forecasting capabilities, particularly when there are considerations of time and computing efforts which slow down the process. But of course, with such developments requires enhanced evaluation to enable trust in the systems. And I think evaluation is one thing that is done well in some ways, but could be improved to have the right evaluation metrics across all forecasting systems for healthy comparison. And of course, best practices will come into any sort of new development like this in order to allow the user to benefit from the forecasts and can begin to trust them more. So I will finish with these thoughts. We have unique forecasting challenges in the Arctic region, and this may well become more important as the region becomes more interesting for users. And there is a forecasting capability at the moment, but it's quite small. Despite this, there are some good practices in place already, but we need to improve the dialogue between people so that the developments go in the right direction and they will be used. And one of the big things of this is to develop the community, and that's something I hope that we are able to do over the coming years. Thank you.
Thank you very much, Heather, for this fantastic presentation. I really like the approach of exploiting all the different works that we have been doing and to put forward some of the results and the outcome that you have shown that are, I think, quite interesting. Our last presentation, last but not least, is by Patrick Hogan. Patrick is the chair of the regional team for North America. He's a leading scientist at the Oceanographic and Geophysical Science and Service Division at NOAA, United States, and he managed a product and services portfolio that covers a wide spectrum of oceanographic topics, ranging from lighting marine resources to Arctic assessment. So Patrick, please, the floor is yours.
Yeah, thank you very much, Enrique, and thank you for the opportunity to present. Next slide, please. So just very briefly, an outline, I'd like to describe how NOAA operational ocean forecasting fits into this larger DCC structure. And then quickly, I'm going to just highlight a couple of our operational ocean projects or products, such as the Hurricane Analysis Forecast System, HAFS, the Real-Time Ocean Forecasting System, that's our global forecast system, RTOS. I'll briefly touch on some coastal operational forecast systems, and finally talk a bit about storm surge modeling. So a lot to get through in a short amount of time. Next, please. Marie earlier mentioned the end-to-end ocean value information chain. This is just another depiction of that, I believe. So I'm sorry about the vertical, having to turn your head to read the slide that way. It's really the only way I could get it to fit. So on the left-hand side of the value chain equation, you have user needs, and those needs fall into available observations and or observation gaps, building capacity, both operational and R&D. And from that, you get knowledge extraction. And then you get into the operational ocean forecasting and prediction part of the chain. And that's the modeling and the prediction, the situational awareness and analysis, the outputs, user-focused outputs, and dissemination. And of course, this then hopefully feeds into informed decision-making and ultimately societal benefits. So I'm going to focus on the modeling and prediction here, of course. Thank you. As part of the working group that Enrique mentioned, we're in the process of putting together a white paper with the goal of trying to align and unify ocean modeling for operations at NOAA. And so we're building this roadmap, outlining the current suite of operational models, and then recommending how we can integrate these and improve these, and try to streamline many of the operational run flows and processes that we have. So the framework is, to identify the different types of operational models we have that can include physical, biogeochemical, fisheries, ecosystem, climate, ice, etc. And then further identify those based on the type of region that they cover, all the way from global down to local and estuarine. The structure, the context is, we're trying to recommend a structure, integration, gaps, working with the other agencies in the U.S. government to try to categorize these and catalog them. There's a user context component, of course, and then ultimately we come up with recommendations for improvements in integration. And I think the linkage here is that this can provide the core for coalescing our contributions to the North American team for DCC. Next, please. So schematically, I think this is how I see it, or how we see it anyway. So the grand scheme is we have the UN Ocean Decade, the ocean prediction theme at the top or at the outside of the onion layer. And then within that, we have the Decade Collaborative Center, which Enrique described earlier. And then within that is the North American team, which I'm here to talk about. And then within that is the government, and I specifically work for NOAA, so I'm only going to talk about NOAA systems here in the interest of time, not the Canadian and Mexican systems. But within the government, we work with the White House Office of Science and Technology Policy and other subcommittees. And then within NOAA, we have the different line offices, the Satellite Group, OAR, Ocean and Atmospheric Research, Ocean Science, Weather Service, etc. We're connected in various ways to other activities such as ETOS, which was mentioned earlier, and also Ocean Predict, 4C, Coast Predict, and other elements of the global enterprise. Next, please. So I want to move on and talk about one of the first operational systems I mentioned. That's the Hurricane Analysis Forecast System, HAFS. And what I'm showing here is just a schematic of how this coupled system is put together. And we just recently implemented what we call a version 2 upgrade. And so right now we're replacing the ocean modeling core from HICOM to MOM6. The other components are shown on the left-hand side here. So it's an FV3 atmosphere, a WaveWatch 3 wave model. Both HICOM and MOM6 for the ocean model versions are running right now. And then you have your regridding and coupling components tying everything together. And so we just quickly on the right-hand side, I'm showing a comparison here of the track skill and the intensity skill over the forecast length over a number of storm cycles. So it's all relative to a baseline. So HICOM is the zero baseline. And when we put MOM 6 in, you can see, particularly in the intensity skill, we're getting improvements in the order of 5 to 10%, which is, as you know, we've had a couple of really devastating storms here in the U.S. over the last month. So, it's a high priority for us to try to get these predictions as accurate as possible. Next, please. And there's way too many details in here for me to go to, but I just wanted to give you this opportunity to, you can go back and look at this or reach out to me and ask more detailed questions. But of the two hurricane systems, prediction systems that we're running right now, this just describes the, the individual components, the resolution, the data assimilation part, the ocean and wave coupling, the physics and whatnot. And we do this over different basins, as you can see on the bottom, for both, and we have different atmospheric, ocean, and wave domains. So next, please. I want to move on and then talk about RTOFs. This is the global forecast system, ocean forecast system, and this just kind of describes the cycling assimilation forecast system itself. So you can't read that very well, but on the upper top left are the ocean observations. So this would, all the operational observing systems, SST, salinity, in situ profiles, altimeter, ice, velocity, etc. This all goes into an Ocean QC module, and from that, we have a data assimilation component that's shown in yellow there. For the global model, it's a 3D var. For some of the coastal models, it's a 4D var. We also have some versions that use the ensemble Kalman filter. And then on the bottom right blue block is the model component. And this can be the ocean model, HICOM MOM 6, the wave model, WaveWatch 3 or SWAN, the atmospheric model, the ice model. And this is a cycling system. So we use tomorrow's forecast from the model as the background for the next cycle of QC, and we cycle through this system on a 24-hour basis. Next, please. So we've recently done an upgrade to RTOS, the regional ocean system. We've added some climatological constraints for temperature and salinity where there are no in situ observations present to control the bias. I'll show you a result from that in the next slide. We've done some other things, improving the mapping to analysis increments. I mean, these are kind of technical details, but it's the version that we've just recently implemented. And of course, a big part of this is to be ready and implement new observation systems, operational observing systems, such as sail drones and marine mammal profiles and SWAT. And we're working on all of those as we go forward. Next, please. So this is just a quick a demonstration of the new system, the VIII system. So you're just looking at two on the left-hand side, the older system on the right-hand side, the new version with the capabilities that I just described. And you're looking on top at the RMS error for salinity. And you can see that the bias or the RMS error, is significantly reduced in the parallel or the new VIII version. So, and the mean bias is already low in both to begin with. So, we see the improvements that we strive to see or that we expected to see. Next, please. So quickly going on to the coastal component, operational ocean components. We have several different coastal systems implemented around the contiguous United States. You can see these these different systems here. Next, please. I'm going to focus just on one, and that is in my backyard, the Gulf of Mexico operational forecast system. So recently, or over the last couple of years, we had all these individual components, such as Houston, Galveston Bay, Sabine ports, Lake Charles ports, except Mobile Bay ports, and we've combined them into one high-res unstructured grid to cover all of them to simplify the operational run stream. So, we have various resolution for the different parts of the domain. It's an unstructured grid. So it ranges, say, from 45 meters to about 1.5 kilometers in Mobile Bay. And you can see the different resolutions in the different bays and ports and rivers represented here in this particular system. Next, please. Last thing I just want to talk about is this storm surge modeling. Again, this is very important for our hurricane forecasting capabilities and needs. So we have what we call the STOFS system. This is Surge and Tide Operational Forecast System. Globally, we have a barotropic or a 2D version of this running. And we also have a 3D version running for the Atlantic. And the next slide is my last slide, and I'll show more detail about that particular system. But we're also developing pre-operationally a STOFS system for the Pacific, or STOFS 3D Pacific. And then in more of a R&D environment, we're looking at STOFS 3D for Alaska. And this is, implementing some new technologies that we've been working on, such as next generation probabilistic, ensemble-based probabilistic storm surge model, an automatic on-demand unstructured grid mesh generator, and also looking at the next-gen coastal ocean coupling infrastructure. So the next slide is just my last slide, and it's just to highlight the 3D Atlantic storm surge, tide and storm surge capability modeling that we have. The core here, the core model is SHISM, semi-implicit cross-scale hydroscience integrated system model. It's forced by NOAA GFS global forecast system winds. For the boundary conditions, it's temperature, salinity, elevation, velocity from RTOFs. It's got tides, and it cycles once per day with a full 24-hour forecast, but a 4-day forecast for the water levels, and the grid resolution is variable, but ranges from about 50 meters to 2 to 7 kilometers. So it's 3D. It's got a vertical mesh shown up in the upper right-hand corner, and just in the lower part here, it just shows you the detail of it's a zoom or zoom in of the New Orleans area. Again, this is my backyard, so I just like to show it. But you can see the very fine detail, the very fine resolution that's required, and it gets the rivers and everything. Yep, so that's fine. This is my last slide. There's just some improvements that we're working on listed below here, and in the interest of time, I'll conclude here. So thank you.
Sorry, I was muted. Thank you, Patrick, for this amazing presentation on the really relevant advances you are having with all these unstructured grids, the different activities. It's amazing the amount of work. And maybe at Europe, we are not sufficiently aware, and maybe have always a feeling that we are not collaborating enough with you. So maybe through the DCC, we can improve that. That's kind of that could be a dream come true if we can advance in this direction, because it's unbelievable the amount of work you are doing, and not that well connected with the work we are doing at Copernicus in Europe. So let's have a dialogue, all of us, and since we are a little bit shorter of time than I expected, which is good because the presentation were fantastic and I did not want to interrupt. Let's go to the key question of the day, because we are talking here about best practices on this event. We are talking about best practices, so how we can promote best practices in ocean forecasting, and what is the expected benefit of doing that? What do you expect at your regions or in your activities from the promotion of best practices, and how we can work in this direction? So feel free, anyone, to start. If not, I will name a volunteer rapidly.
Well, I'd like to say that for us, a key issue in the best practice that we should implement in our system, in the Brazilian Navy system, is data dissemination. It's a key point that we have been pursuing that for a while, but by lack of resources and some limitations, because our system is hosted by the Brazilian Navy, we had difficulties so far. But in 2025, we have allocated new resources to do this task and have a more intelligent way of providing not only the forecasting NetCDF files, but also some thread or some specific tool to visualize remotely with respect to the user point of view, some figures and so on. So I think this is very important for us. And maybe the GCC portal also could host some of these forecasts as well, because so far we are not keeping the forecasts in our disk. We're keeping a limited forecasting time because of the rigid disk limitation. But it would be very nice, and then next year I think we will be meeting this very important demand.
Okay, Clemente, that's very interesting. Let me think. With respect to that, Maria and myself and others, we are going to start soon an activity devoted to try to identify the need required with data standards in ocean forecasting, and that can link with your wishes of better data sharing, because we are going to do a reflective, general thinking in our community on how we should organize this properly, because this is far from trivial. I have to say that after being working in many years, I would not say how many, in ocean forecasting, when I really came down to explain how the data should be stored, I realized that there was a lot of things that I was not doing properly in the past. So it will be very good if we can explore together all this, and we can come next year with a common publication on how we believe we have to structure and save the data of our ocean forecast in order to be shared. Of course, this is one of the steps. It's not the solution. It's just one of the steps. So, Marie, please, you have raised your hand first.
Yes, thank you. I was, maybe complementing what you just said about the sharing data and the improving the exchange of data in between centers and improving our capacity to intercompare the solutions is, I think, very important. Also very egoistically, or for my project of intercomparison, of course. But what I mean is that project is really has a strong motivation. The strong motivation behind this intercomparison project is also to improve the quality of our products and to understand how we can use them for machine learning applications, for instance, or for other digital twin applications in the future. And we really need to understand how we can speak the same language and compare the same variables on the same grids. This is about formats, but also about tools that we are going to be develop in the near future to really be able to do this intercomparison.
So, Marie, I don't have to. Sorry.
No, that's
So
basically.
I certainly don't have to explain that part to you, but remember that in our architecture, one of the data standards that we have identified is the one related with the model intercomparison. And I think that will be fantastic next year when we start working on this line, because here I think we are really having an empty canvas on how to build this thing and how to do recommendations. So I think that could be very powerful exactly to promote what you are suggesting, and I hope that will be good for your project.
Yeah, and also I think the data sharing will come together with the model validation, because there are many scripts and tools already ready to validate the model. So it will be one step is, the first step is difficult, but the second and the third, I think maybe it will be easier because of the whole infrastructure that we have available.
And the arrival of the digital twins will be important also as an infrastructure. If we facilitate that the data is in well-organized data standards, then the digital twins will be able to digest a more healthy information, more nutritive information, let me say it that way. It will have all the required metadata, it will have everything. And that also applies to the cloud that I think it applies to the cloud that CostPredict is planning to build. Same kind of thinking is useful for this cloud in my opinion. So Giovanni, the floor is yours to reply this question on best practices.
Well, yeah, I mean you perfectly told already what I wanted to say, so I just repeat that I think we are the WMO of the ocean. So we are this is the community. And in addition to develop the best practice, and we are here for that, on how to share the data, the proper amount of data, so not all the data, but the proper amount of data useful for the application, the intercomparison, among the others aspects, and the machine learning component. We need really to build the infrastructure, and it cannot be a top-down. I mean, best practice can be defined as a community. Then we need to connect the systems in the different continents, and probably, as Enrique was underlined, the cloud approach that Europe, but also US and Australia probably are developing, are embracing, I think is the right way, where different cloud in different regions at the global, at the regional level for sure, and also we are trying, as Enrique was saying, at the coastal level, I think they should interconnect. And then the applications, first of all, I agree with Marie and Enrique, the validation and intercomparison and validation will be key, but also all the other exploitation. It's important that we really, our centers share the data on a cloud and they flow, they go. And then people will, so that I think is our objective, Enrique and all, and let's build it together.
Okay, that's fantastic. Sounds great, Giovanni. Sounds absolutely great. I would like to hear if you agree, Heather, your vision on this issue of the best practices and how can we promote this and how can this benefit the activities in your region?
Yeah, I would say that the validation is an important one because of the uncertainties involved with Arctic forecasts and the importance of not getting the sea ice wrong in certain metrics. I think that some of the metrics that are often used to validate sea ice models aren't the best for forecast specific applications, and those are the ones that can get users to start trusting the forecasts more. So a validation across models and to see which ones can be used in which circumstances is very important, especially as some of the variables, as I said, aren't necessarily the exact ones that the users might want. So a way to interpret those, I think, scientists are used to interpreting uncertainty a bit different to some other users, and a way to understand what that means for a forecast in simpler terms or more easy to absorb terms, I suppose, could be important. So having a uniform way of dealing with forecast outputs and validation may help to see, for users to see how the sea ice models are doing and which ones they might want to use for what.
Okay, thank you for this comment. I think that in this related to this, maybe the incoming publication of the operational readiness level document could be a little step forward in this direction, because remember, one of the numbers on the ORL is related to validation, and you will have we will have there a set of best practices, maybe kind of basic or let's say not very oriented to one specific variable, but at the end of the day, it will be a very good guidance to check if we are doing things at least on the basic level properly, because the operational readiness level is just the experience of a bunch of people that have been working on this, put together on a document, and it's a common experience, and I believe there's a lot of accumulated experience on that. So therefore, it can be a good step forward, certainly not the solution, but a good step on the right direction. And we are just missing some words from Pat. So maybe you can share with us your view on this topic.
Yeah, the advantage of speaking last, I suppose, is to agree with everything that's already been said, and I certainly do that. I think, machine learning and AI are going to be important aspects of our work going forward, and what Heather just said about uncertainty. As we go to coupled high-res systems, running ensembles to generate uncertainty and do ensemble DA, and then lastly, I think coupled data assimilation, I think, can really be powerful in areas like the Arctic and for hurricane forecasting and other types of very process dependent forecasting like that. So the intercomparisons and the model validation are all very important. It's always a question of what data do you withhold, not assimilate into your model for the validation. That's always a consideration that we take into account. So yeah, lots of exciting things to do going forward.
Thank you, Patrick. So I checked my clock, and unfortunately, we are 2 minutes beyond the closure time. I think that was a fantastic panel. I hope there will be a lot of people on YouTube watching it, and we have had some assistants here, some people being here. Not that many. This morning it was more populated. Maybe depends on the time zone. But I think it was a fantastic set of presentation, and I really thank all the speakers for all the excellent presentation and for the nice dialogue. It's a pity we have to close it now, because I was personally having a good time with the dialogue. But see you next time, and thank you very much to everybody for being here. Bye-bye.
Bye-bye.
Bye-bye. Thank you.
Thank you.